So this video is on empirical formulae. And our objectives are, by the end of this video, hopefully you'll be able to define empirical formula. That's one of the definitions you have to know for your exam. To determine the empirical formula when given data to do so, and to understand the relationship between an empirical formula and a molecular formula. Now, you'll have come across empirical formulae at GCSE if you did triple science, but not in great depth, and you need to understand it in a bit more depth at A level. So first, what is an empirical formula? So the word empirical means basically derived from observation or experiment. So an empirical formula is one that you can work out doing an experiment. You can't always work out the molecular formula, but you can use the empirical formula and other data to work out the molecular formula of a compound. The actual definition you have to know for the empirical formula is that it is the simplest ratio. I'm going to write it out because it's important. The simplest ratio of the atoms present in a substance. Okay, and that, probably in different words, that definition is going to be in your AS textbook in the glossary at the back. So how do you actually calculate empirical formula? So what I'm going to do is go through the steps you have to follow to calculate empirical formula. Then I'm going to go through a couple of examples in the next couple of slides. So to calculate empirical formula, there are 4 steps you have to follow. If you remember these 4 steps, then you'll be able to answer the question. And the first step is to use the information that is given to you in the question. So you'll either be given percentages or masses, and these percentages and masses represent the amount of one element there is in that compound. And what you have to do with those percentage masses, it doesn't matter if it's a percentage or a mass, you do the same thing with either, is that first step, you divide by the relative atomic mass, the AR, of the element it represents. So, for example, if the percentage or mass represented carbon, it would be 12. If it represented oxygen, it would be 16. And so on. The second step is to do with the numbers that you will then create from the first step. And what you have to do with those numbers is divide by the smallest number that you have created. So for example, if your 2 numbers or 3 numbers that you get, I'm going to show you an example with 2, are 0.25 and 0.5, you will divide both of those numbers by 0.25. The third step is based on the ratio that the second step will then give you. And what you do in the third step is you either round or you multiply that ratio in order to get integers for the ratio. So round or multiply to get integer, so whole number values. So for example, if you ended up with a ratio of 3.98 to 1, that would round, quite obviously, to 4 to 1. However, if you got 3.5 to 1, then you wouldn't round this time because it's not appropriate. You'd have to double both numbers to get 7 to 2. The times you would round are going to be very obvious. They'll either be something 0.99 or something 0.98, or it'll be something 0.01 or 0.02. If it's either 0.5 or 0.33 or 0.25, then you're going to multiply by either 2, 3 or 4, depending on what the number is. And the last step is actually to answer the question, because the question doesn't ask you for the ratio, which you'll have calculated in step 3. It doesn't ask you this ratio, it'll ask you for the empirical formula. So let's say that this 7 to 2 is the empirical formula for carbon to oxygen. So I have a compound with carbon and oxygen in, and the ratio I've worked out is 7 to 2. You will then work out the answer. So 4 is right answer. And you'll be surprised how many students actually forget to do that last step because they think they've got the ratio and then they're done, but actually they've got to write the answer. So for example, C702, if you're using the ratio I've just worked out and those elements that I've used for examples in previous steps. So let's look at an example. So here we've got a question where it's asking us to work out the empirical formula of an oxide of nitrogen based on the results here. Now it may seem like we've only got one result and one percentage, but actually we've got to work out the other percentage by what they've told you, so we'll get to that. So we're working out an empirical formula of an oxide of nitrogen, and now that tells us that basically we've got nitrogen and oxygen joined together. There's going to be nothing else in the compound, just nitrogen and oxygen. So they've told us what the mass, the percentage of nitrogen is in the compound. So if that much is 30.4% of the compound is nitrogen, that means the rest of it must be oxygen. So the first thing we do is work out the percentage. Sorry, I don't really want to use the red. I want to use blue. First thing we're going to do is work out the percentage of oxygen, and that's going to equal 100 take away 30.4. So that gives us 69.6. Now we've got two numbers. We've got one that equates to nitrogen and one that relates to oxygen. And what we're going to do is divide those two numbers by the atomic mass of the atom they represent. So for nitrogen, that is 14. If you look at it up in the periodic table, the relative mass of nitrogen is 14. So we're going to divide that by 14. By the atomic mass, and then we're going to divide 69.6 by the atomic mass of oxygen, which is 16. That will then give us two numbers, which are 2.17 to 4.35. And that gives us a ratio, but it's not a very useful ratio because they're not integers. You can't get 0.35 of an atom of oxygen. So what we've got to do is divide them both by the smallest number, so that's our next step. So that was our second step in the previous slides. We're going to divide both by 2.17 and the other one by 2.17, and that gives us a ratio of 1 to 2.005. Now this one, obviously we're going to round to 1 to 2. Now that isn't the last step. What you must do then is write the actual formula, because what they're asking you in the question is to calculate the empirical formula, not just the ratio. They want you to put down the formula. So this basically tells us there is one nitrogen for every two oxygens, and so the formula is going to be, from that ratio, NO2. And that is our answer. So this next example is an example of a slightly more difficult question they may ask you to do with empirical formulae, but it's worth the same number of marks as the last question. And they're basically asking you to work out a value for X. Now X represents the number of water molecules that attach to this compound here, which is calcium nitrate, when it's hydrated. So when it's surrounded by water, this number of water molecules will surround this compound because it's attracted to it, basically. Now to do this, you essentially do exactly the same as you did before, but instead of using the mass of atoms, you're going to be using the relative mass of this and of this, because basically you're trying to work out a ratio of calcium nitrate to water. But first you've got to work out how many grams of each you've got. So it tells in the question you've got a 6.04 gram sample of the calcium nitrate attached to water, and of that, 1.84 grams of it is water. So you've got how much water you've got, so you've got, just write it out, 1.84 grams. Now, what you now need is the mass of just calcium nitrate in this compound, because you're trying to work out the ratio of calcium nitrate to water. And to do that, we've got to take away this water from this mass here. So to work out calcium nitrate, we're going to do 6.04, take away 1.84, and that gives us a number of 4.2. micrograms as well. Now what we've got to do is work out the relative masses of the water and the calcium nitrate, because that is what we're going to be dividing these two masses by in order to get a ratio. So water, as we know, has a relative mass of 18, that's 16 for oxygen, plus 2 for each of the hydrogens. Sorry, 1 for each of the hydrogens, there's two of them altogether. And the relative mass of calcium nitrate, if you work it out, is 40 plus 14 plus 14, because there's two of them in the formula, plus 6 times relative mass of oxygen, which is 16. So that's 40 plus 28 plus 96, and that gives us a relative mass of 164. Now we've got all our numbers, we can go through the process of working out the empirical formula. So the first step is to divide our masses that we've got by our relative masses. So what we're going to do is divide 1.84 by the relative mass of water, which is 18. I'm going to divide 4.2 by the relative mass of calcium nitrate, which is 164. That will give us a ratio, which is 0.102 to 0.0256. That ratio means nothing really, so we've got to divide both by the smallest number, and the smallest number is 0.0256, so we're going to divide both by that. And that gives us a new ratio of 3.98 to 1, and that'll round to 4 to 1. So remember that this number here was from this 1.84, which number of waters, and this number here was from the 4.2, which was the calcium nitrate. So that means that for every 1 calcium nitrate, there are 4 waters in this equation. So that means that we can give an answer. Remember, you always got to give an answer, and what they're asking for here is to work out a value for x. So your answer in the end is going to be x equals 4. Now, this last bit is going to be fairly straightforward, just to understand the relationship between empirical and molecular formulae. Now, as I said at the very beginning, you can work out an empirical formula from experimental data. And you can also work out the mass of a compound, the relative mass, sorry, also using experimental data if you to use mass spectroscopy. So that means if you can work out the empirical formula and the relative mass of a compound, you can also work out the molecular formula. So, for example, if we had an alkane and we knew its a compound, and we knew its empirical formula was CH2. And from a mass spectrometry calculation, we worked out that the relative mass of the compound we have was 42. We can now work out what the molecular formula is of the compound, because we know that the mass of CH2, the relative mass of this, is going to be 12 plus 2, which equals 14. Now, if we do 42 divided by 14, that equals 3. That means the molecular formula must be made up of 3 of these, 3 of the empirical formula, because the molecular formula is going to be a ratio that is the same as the empirical formula. So that means the molecular formula of this unknown compound has to be C3H6. Please come and see me if any of this doesn't make sense, and I hope it does after this video.